Let's look at this graph which we have from our last tutorial. The vehicle whose journey we started was traveling at 5 meters per second and accelerated continuously at 5 meters per second squared for 5 seconds. Time is represented on the x-axis in intervals of 1 second. Velocity is represented on the y-axis at intervals of 10 meters per second. The vehicle at this point is traveling at 5 meters per second, and each second the velocity increases by 5 meters per second. The velocity is changing and we get this line with a positive slope. The vehicle started at A and traveled to B in time OC. This is the initial velocity at A, we called it U. This is the final velocity at B, which we named V. Now let's draw the lines we'd drawn in the previous video. Don't forget, we want to prove the second equation of motion in this video. From B, we drew lines to the time and the velocity axis. We have BE and BC. We also drew AD to help us see the difference between the initial and final velocity. We have seen previously that the distance travelled by the vehicle equals this shaded portion under the line. If you wish to review this, you can refer to our previous tutorial on velocity time graphs. Now let's call the distance travelled S. So now the distance travelled in time t equals the area of OABC. What is this shape? Is it a rectangle? Is it a square? No, it's a trapezium. Let's have a quick quiz on trapeziums. Do you remember how many sides a trapezium has? Correct. A trapezium has 4 sides, which makes it a quadrilateral. Do you remember what special property this particular quadrilateral has? Correct. It has one pair of sides parallel. The formula for the area of a trapezium is 1/2 the sum of the length of the parallel sides times the distance between them. But let's say you'd forgotten this formula. How would you calculate the area of this trapezium? Easy. S equals the sum of the area of rectangle OADC and the area of triangle ABD. Why did we do this? Because it's easier to remember the area of a rectangle and a triangle. Area of the rectangle equals length times breadth, which is OA times OC here. Area of the triangle equals 1/2 times the base times the height. So here it'll be 1/2 times AD times BD. Let's substitute OA, OC and BD. OA equals U, OC and AD equal T, and BD equals A times T. Do you remember how we'd got BD equals A times T in the last video? BD is nothing but the change in velocity, and acceleration is change in velocity over time taken. We get A equals BD over T, and hence BD equals A times T. Now we have distance S equals U times T plus 1/2 T times AT. Distance S equals U times T plus 1/2 A times T squared. So now we know that with a velocity time graph, we can calculate the acceleration as well as the distance covered. So the two equations we've derived are V equals U plus A times T and S equals U times T plus 1/2 A times T squared. We will derive one more equation of motion in the next tutorial.